Hey guys, turn to page 48, and we are going to go over three types of functions that we learned: linear, exponential, and quadratic. Now, here you see that a linear function is a straight line. We remember the equation is y equals mx plus b. An exponential function is curved, and you remember that the function is y equals ab to the x. And the quadratic function we just did, and it's y equals ax squared plus bx plus c. So since you know if it graphs to be a straight line, you know it's linear. If it graphs to be a curved line, you know it's exponential. And if it's a u, you know it's a quadratic. One way to identify what these look like is to actually graph them. So on page 48, what I'd like you to do is actually graph the data. And when you're done, turn the video back on and see if you agree with me. But by graphing these points, you should be able to determine what type of function it is. So stop the video and graph the points. Okay, by now you should have graphed the points, and you should have discovered that A, those points made a parabola, so it's quadratic. In B, those points made a curved line, it's exponential decay. And in C, those points formed a line, so it's linear. So one way to determine what a set of data, what type of function it is to actually graph the ordered pairs. But we're not going to want to graph every single time we see data. So there is another way, if you're given a table, to determine what type of function this is. Now, the way we determine it is we look at what's called the first difference, the second difference, or we see if there is just a common multiple. So you can read through these rules, but first I'm going to actually go through examples with you. So let's look at table 1. Now, all of these rules only work if x is increasing by the same amount each time. So if you're given a function and x is not increasing by the same amount each time, you can't use these rules. But let's look at the first one. We see that x is going up by 1 each time. Let's see what is happening to y. So this is plus 1, plus 1, plus 1, plus 1. Y is plus 4, plus 8, plus 16, plus 32. Now, I'm saying, okay, maybe I shouldn't be looking at that as plus 4, plus 8, plus 16, or 32. Now that I'm looking at it again, I'm like, you know what? Each time it's being multiplied by 2. Times 2, times 2, times 2, times 2. Now, I know that if there is a common ratio or a common multiplier, that this is exponential. And I remember when we did this before, that the common multiplier was b. So I know this is an exponential function, and I'm going to come up with the rule. And I know the rule is y equals ab to the x. So I know b is 2. So how am I going to find out what a is? Because I remember we learned in class, we looked when x was 0, the y value was a, but there is no 0 value here. So you can do this one of two ways. You can say, well, I can extend the pattern. This, if I go down 1, this is 0, and here I do 8 divided by 2 is 4, so 4 divided by 2 is 2. So my guess is this is y equals 2 times 2 to the x. But I wonder if there's another way I can check. And then I remember, oh yeah, there is another way. I can substitute 1 for x and 4 for y. So I can say 4 equals a times 2 to the first. 4 equals 2a, so a equals 2, and I realize I'm correct. Okay? So because this had a common multiplier, this was exponential. I remember the multiplier is b. A is the y-intercept when x is 0. If I can't figure out what y is when x is 0, I just pick a point and plug it in. Now, let's go over table 2. Okay, this time I'm going to look and say, no, I don't think this is a multiplier. I think this is plus 4, plus 4, plus 4, plus 4. So this is what we call a common first difference. When you look at the difference in the y values and it's an arithmetic sequence, that's called a common first difference. So this means that my slope is the change in y over the change in x. So it's 4 over 1. So this is y equals 4x plus b. How do I find b? I plug in a point. So I say 4 equals 4 times 1 plus b. b equals 0, so my equation is y equals 4x plus 0. Okay, and that's definitely linear. Now, let's look at the last one. The last one, x is going up by 1, but y okay, that is certainly not a common first difference. So let's see what the second difference is. And that means, what do I do to 4 to get 12? I add 8. What do I do to 12 to get 20? I add 8. I add 8. I add 8. So this is a quadratic because quadratic functions have what's called a common second difference. Okay? Now, to come up with your equation, here, if we look down at the bottom, it says for a quadratic equation, your a ends up being your common second difference divided by 2. C is your y-intercept. It's the value of the function when x is 0. And to find b, you substitute. So in this specific example, my a would be my common second difference divided by 2. So y equals 4x squared plus bx, and my c is when x is 0, it's my y value. So I know that my equation would be y equals 4x squared plus bx minus 1. The 4 I get from taking my common second difference and dividing it by 2. My c I get by finding the value, or looking at the chart they gave me. When x was 0, y is negative 1. That's how I got c. Now, to find b, I just have to plug in a point. So I will plug in the point 1, 3. So 3 equals 4 times 1 squared plus 1x minus 1. So 3 equals 3 plus x. So x equals, well, I'm sorry, I'm solving for b. b equals 0. So this equation would be y equals 4x squared minus 1. Okay, and the rules for the quadratic equation are written there. Now, let's turn the page and try to see if we can figure out some other ones. So we're going to look at example A. So I look to see what kind of difference this is. This is adding 4, adding 4, adding 4, adding 4. So this table, since it has a common first difference, represents a linear function. And I know this is my slope is this, the change in y over the change in x. So I know my equation is y equals 4x minus 4. I want you to think about how I found the y-intercept so quickly. Do you think I substituted a point that quickly? Or do you think I looked and noticed when x was 0, the y-intercept has to be -4? Okay? If we look at the next one, I notice here I don't think there's going to be a common difference. There's going to be a common ratio. If I do 4 divided by 2, so this is 4 over 2, which is 2. This is 2 over 1, which is 2. This is 1 over a half, which is 2. And this is a half over a quarter, which is 2. So I know that B equals 2. Now I also know A equals 1 because A is the value of y when x is 0. So this equation is y equals 1 times 2 to the x, and I did not have to put the 1. So this is definitely an exponential function. Now I want everybody to turn the video off, and you're going to try to do checkpoint number 1 and 2, and then check after you do it. Okay, so if you're turning this back on, that means you have done this already. If we look at number 1, we notice it is a linear equation, and the equation is y equals 2x plus 3. And number 2, you would have noticed there's a common second difference, and the equation would be y equals 3/4 x squared. Okay, so now you can stop the video and check the homework.